Hey guys, so today we are going to be looking at imaginary numbers. So we're going to look at an introduction to imaginary numbers. So I know that sounds weird because how can a number be imaginary? But these are especially important because sometimes when we're solving equations, we end up with negatives under the radical or as the radicand. And so it's really important for us to have a way to explain that, and that's where our imaginary numbers come in. So why do we need these? Well, we know that the square root of 25 is just 5. Why? Why is the square root of 25 5? Well, because 5 times 5 equals 25. So by definition, the square root of 25 is 5. But then how can we explain the square root of negative 25? Well, you might say that it's negative 5, but negative 5 times negative 5 equals positive 25. So that can't be it. So imaginary numbers give us a way to solve when there is a negative under the radical. So what is this imaginary number? Imaginary number is I. That's how we label it in mathematics. So pretty much always when we see this lowercase I in mathematics, it means imaginary number. And it's the square root of negative 1. So it's equal to the square root of negative 1. That's by definition. That is something that you should know and remember and memorize and eventually come naturally to you. What that means then is that I squared equals I times I, or the square root of negative 1 times the square root of negative 1, which by definition equals negative 1. So when we see an I squared in a problem, we can simplify that or substitute negative 1 in its place to become a real number rather than that imaginary number. Because that square root of negative 1 times square root of negative 1 just equals negative 1. So now here, we've got I to the third. That's just I times I times I, which is the square root of negative 1 multiplied by itself 3 times. Well, within this, we have that negative 1 again times the square root of negative 1. And we know that this square root of negative 1 here just equals I. So this would simplify to the negative square root of negative 1, or just negative I. So I to the third power simplifies to negative I. And then I to the fourth. Well, we've got 4 i's being multiplied together, or 4 square roots of negative 1 being multiplied together, which is, that each of those sets, each of those doubles of square root of negative 1 being multiplied together is just negative 1. Well, negative 1 times negative 1 just equals 1. So I to the fourth equals 1. Well, let's then move into I to the fifth. So that's 5 i's being multiplied together. Well, here I have 4 i's. And I know that's I to the fourth, which we just said equals 1. Right? So that just equals 1. So I to the fifth is I to the fourth times I, which is just 1 times I, which equals I. So I to the fifth we can simplify to be just I. I to the sixth then, well, if we know that 4 of them equals 1, then I've got I to the fourth with 2 left over, so I squared. And I know that I squared equals negative 1. So 1 times negative 1 is just negative 1. I to the seventh then, well, we've got 4 i's, and there's 3 left over. So we've got I to the fourth times I to the third, so 1 times I to the third, which is just I to the third, which we remember as negative I. So that I to the third then just equals negative I, if we're fully simplifying it. And then I to the eighth, we've got 4, and then 4 more. So that's I to the fourth times I to the fourth, which is just 1 times 1, which is 1. So this pattern I, negative 1, negative I, 1, repeats every multiple of 4. So what that tells us and what that means for us is actually a good thing. What do we actually need to remember? We need to remember that the square root of negative 1 is just I. And then we get the pattern that I squared is negative 1, I to the third is negative I, and I to the fourth is equal to 1. And remembering this pattern allows us then to simplify any exponent of I. So let's look at simplifying powers of I. If we have I to the 13th, well, instead of having to write out 13 i's and then group them into 4s and then see how many are left over, one thing that we can use to show grouping in mathematics is division. So we could divide this into groups of 4. So we would divide the exponent by 4. 13 divided by 4 gives me 3 with a remainder of 1. And then I can use that remainder to determine the simplified power of I. So if I have a remainder of 1, that means I had 1 I left over, which means I to the 13th just equals I. So let's look at another one. I to the 26th. Again, who wants to write out 26 i's? Make sure you actually have 26 there. Circle your groups of 4 to cancel them out because they're just 1 and see how many are left over. No one wants to take all that time. So, because we know that this pattern repeats every 4, we can divide the 26 by 4. We end up with 6 with a remainder of 2. We don't care about that 6. We only care about the remainder, right? Because that means there were 6 ones being multiplied together. It still just equals 1. The remainder of 2 then says there's an I squared left over, and we know that I squared equals negative 1. So I to the 26 equals negative 1. How about I to the 127th? Why don't you pause the video and give it a try? So if we divide 127 by 4, we get 31, the remainder of 3. A remainder of 3 tells us there were 3 i's left over, so I to the third, which simplifies on its own to negative I. So I to the 127th equals negative I.